Look up on a clear night, far from the glare of city lights, and you might catch a glimpse of a pale silken ribbon stretching across the sky. To the naked eye, it appears soft, almost like mist. But that faint glow is something far more extraordinary. It is the Milky Way, a sprawling spiral of stars, gas, dust, and mystery. A galaxy that is not only vast beyond comprehension, but also home. For thousands of years, humans have gazed at this glowing band and asked timeless questions. What is the Milky Way? Where exactly are we inside it? Is our sun special, or just one among billions? And what secrets lie hidden in the galactic heart, in the dark spaces between the stars, in the distant arms we may never reach? This is more than a scientific journey. It is a story about perspective, about understanding how something unimaginably vast can still shape the smallest details of our lives. Join us as we set course on a voyage through the Milky Way, a journey from our cosmic doorstep to the farthest edges of our galactic home. The solar system is our cosmic neighborhood, a beautifully structured collection of celestial bodies bound together by gravity. At its center lies the Sun, a middle-aged yellow star that provides the energy necessary for life on Earth. Orbiting the Sun are 8 planets, from rocky inner worlds like Mercury and Venus to the gas giants Jupiter and Saturn, and the icy realms of Uranus and Neptune. Alongside these planets are moons, dwarf planets, asteroids and comets, each following paths carved by the laws of physics in a cosmic dance that has lasted for over 4 billion years.
Beyond the orbit of Neptune, the solar system continues into a darker and colder region known as the Kuiper Belt. This vast zone stretches from approximately 30 to 50 astronomical units from the Sun. 1 astronomical unit equals the distance between the Earth and the Sun, about 93 million miles. The Kuiper Belt is filled with icy remnants from the early solar system, including dwarf planets like Pluto and Haumea. These ancient bodies are frozen time capsules, preserving material left over from the birth of the planets.
But the solar system does not end there. Extending far beyond the Kuiper Belt is a nearly incomprehensible region known as the Oort cloud. Though still theoretical, scientists believe it forms a giant spherical shell of icy objects, reaching nearly a quarter of the way to the nearest star. This marks the outermost edge of the Sun's gravitational influence. Within this great sphere lies a protective boundary that shields us from much of the galaxy's harshest radiation, an invisible force field called the heliosphere. The heliosphere is a colossal bubble carved out of the interstellar medium by the solar wind, a constant stream of charged particles flowing outward from the Sun. This wind carries with it the Sun's magnetic field, stretching far into space and shaping a dynamic frontier between our solar system and the rest of the galaxy. Like an atmosphere that surrounds an entire planetary system, the heliosphere acts as a first line of defense against high-energy cosmic rays and particles that travel through interstellar space. As the solar wind pushes outward, it eventually encounters resistance from the surrounding interstellar medium. This marks the beginning of a boundary region known as the termination shock. Here, the solar wind slows down dramatically from supersonic speeds as it collides with incoming interstellar particles. Beyond this turbulent zone is the heliosheath, a transitional layer where the solar wind continues to lose strength. Eventually, it reaches the outermost boundary of the heliosphere, the heliopause. The heliopause is the point where the solar wind is no longer strong enough to push back the interstellar medium. It is the frontier where our solar system ends and true interstellar space begins. Located roughly 11 billion miles from the Sun, the heliopause is a shimmering veil, fragile yet powerful, that separates us from the unknown. It is here that the influence of our star fades and the galactic environment takes over. Beyond this boundary, space becomes colder, darker, and filled with particles of a different kind. This enormous magnetic bubble is more than a curiosity. It is essential to life as we know it. Without the heliosphere, cosmic radiation from deep space would flood into the inner solar system. High-energy particles could strip away atmospheres, damage DNA, and prevent the stable conditions necessary for life to evolve. Earth's magnetic field and atmosphere offer additional protection, but the heliosphere provides the first, most far-reaching shield. In essence, it is the Sun's invisible armor, a silent protector stretched across billions of miles. The solar system, with all its planets, moons, belts, and clouds, is not isolated. It orbits within the Milky Way galaxy, making one complete revolution every 250 million years. And yet, in all that vast movement, it remains cocooned in this magnetic bubble, an oasis of relative calm in a turbulent galaxy. The heliosphere reminds us that even in the depths of space, there are forces working to preserve the fragile balance required for life. It is a testament to the interconnected beauty of the cosmos and our place within it. The solar system is part of a vibrant neighborhood within the Milky Way. Though space is vast and mostly empty, our corner of the galaxy contains a handful of nearby stars that offer a glimpse into the variety and mystery of the cosmos. These stars, just a few light-years away, include some of the brightest beacons in the night sky, and some of the quietest, faintest embers. Among them are the Alpha Centauri system, Barnard's star, and the dazzling Sirius, each offering its own unique portrait of stellar evolution and planetary possibility. When we look to the southern skies on a clear night, one of the brightest stars visible is not a single point of light at all. It is Alpha Centauri, the closest stellar system to our own Sun. From Earth, it appears as a single star, but behind that shining glow lies a complex family of 3 suns, locked in a cosmic dance just over 4 light-years away. This system, though distant by human standards, is our nearest neighbor in the vast wilderness of interstellar space. The Alpha Centauri system consists of 3 stars. The 2 brightest, Alpha Centauri A and Alpha Centauri B, form a binary pair, 2 stars orbiting around a shared center of gravity. They are both similar in size and color to our Sun, and they revolve around each other once every 79 years. A third, much fainter star, Proxima Centauri, orbits the pair from afar. Though it is not easily visible to the naked eye, Proxima Centauri holds a special distinction. It is the closest known star to the Sun. Proxima Centauri is a red dwarf, a small and relatively cool star with just a fraction of the Sun's mass and brightness. Despite its dim light, it has captured global attention in recent years. In 2016, astronomers discovered an Earth-sized planet orbiting Proxima Centauri. Named Proxima b, this world lies within the star's habitable zone, the region where temperatures might allow liquid water to exist. Since then, 2 more candidates have been found. Proxima c, a larger and colder planet farther out, and Proxima d, a tiny planet orbiting extremely close to its host. Of these 3, Proxima b is the most intriguing. Though it is slightly more massive than Earth and likely rocky, its environment would be very different. Because Proxima Centauri is so dim, the planet must orbit very close to receive enough warmth. So close that a year there lasts only 11 Earth days. The proximity also means it is bombarded by powerful stellar flares, which could strip away an atmosphere or bathe the surface in harmful radiation. Still, if Proxima b has a magnetic field or a protective atmosphere, the possibility of life cannot be ruled out. The Alpha Centauri system stands as a symbol of what may lie just beyond our reach. It is close enough to dream of visiting, rich enough in planetary interest to inspire missions, and familiar enough in stellar composition to feel like a second sun. With each new discovery, it becomes a stronger candidate in the search for life beyond Earth. Perhaps one day, humanity will send robotic explorers, or even ourselves, across the gulf of space to reach our nearest neighbors. Until then, Alpha Centauri remains a brilliant promise, twinkling from the darkness, reminding us that we are not alone in this galaxy. Not far from the Alpha Centauri system lies a far more ancient and quiet neighbor, Barnard's Star. Located just over 6 light-years from Earth, it is the second closest stellar system to our Sun, and one of the most studied red dwarfs in the sky. Though it is too faint to be seen without a telescope, Barnard's Star has intrigued astronomers for more than a century. Not for its brightness, but for its incredible motion. Barnard's Star holds a unique distinction. Of all the stars visible from Earth, it has the fastest apparent motion across our sky. This is called proper motion, and Barnard's Star races across the celestial sphere at a speed unmatched by any other star. Its movement is so rapid that its position noticeably shifts even over the course of a human lifetime. This swift drift through the galaxy hints at a long and storied journey, one that began billions of years ago. Classified as a red dwarf, Barnard's star is a small, cool, and remarkably long-lived type of star. It burns slowly and steadily, with only a fraction of the Sun's mass and luminosity. In fact, its surface is so dim that, were it to replace our Sun, Earth would freeze solid in moments. Yet, what it lacks in brilliance, it makes up for in age. Barnard's star is estimated to be more than 10 billion years old, twice the age of our Sun, and among the oldest stars in our stellar neighborhood. In recent years, this ancient star has revealed a surprising secret. In 2018, astronomers detected a strong signal suggesting the presence of a planet, Barnard's star B. This world is thought to be a super-Earth, a rocky planet at least 3 times the mass of Earth. It orbits at a distance where temperatures are likely far below freezing, in a region often called a snowline. If confirmed, Barnard's star B would be one of the oldest known planetary systems, formed in the early days of our galaxy. The discovery of Barnard's star B is more than a curiosity. It shows that planets can form and persist around even the oldest and faintest stars in the galaxy. It raises important questions about the potential for ancient forms of life, the stability of planetary systems, and the long-term evolution of exoplanets. In a cosmos where stars are born and die in cosmic blinks, Barnard's star reminds us that some celestial fires burn quietly for eons, and may shelter worlds that have waited patiently to be found. Among the countless stars that fill our night skies, one shines brighter than all the rest. Its name is Sirius, a beacon of brilliant white light visible even from cities, glowing with a sharpness that cuts through the dark. Known since antiquity and revered across cultures, Sirius is more than just a luminous star. It is a system, a mystery, and a milestone in our understanding of stellar evolution. Sirius lies just over 8 light-years from Earth in the constellation Canis Major, or the Great Dog. This is why it is often called the Dog Star. To the human eye, Sirius appears nearly twice as bright as the next brightest star, due to both its proximity and its intense luminosity. Sirius A, the primary star, is about twice the mass of the Sun, and nearly 25 times as luminous. Its searing surface burns at over 9,000 Kelvin, emitting a blue-white glow that dominates the winter sky. But Sirius is not alone. Hidden within its brilliance is a second, much smaller companion, Sirius B. This faint object cannot be seen without a telescope, but it has a story that changed astronomy forever. Once a massive star, Sirius B exhausted its fuel long ago and collapsed into a white dwarf, a dense Earth-sized remnant packed with mass. It was the first white dwarf ever discovered, and its existence confirmed theories that stars could end their lives in quiet, compact forms. The 2 stars in the Sirius system orbit one another every 50 years in a graceful elliptical dance. Though invisible to the naked eye, the presence of Sirius B was predicted before it was ever seen, based on subtle wobbles in the motion of Sirius A. In the mid-19th century, astronomers confirmed its existence, and in doing so, opened a new chapter in stellar physics. Sirius B became the prototype for an entire class of stellar remnants, helping scientists understand the ultimate fate of stars like our Sun. Beyond science, Sirius has held symbolic meaning for thousands of years. The ancient Egyptians aligned temples to its rising. Its return to the sky marked the flooding of the Nile. In Greek mythology, it was a harbinger of summer's scorching heat. Even today, Sirius continues to inspire, from cultural myths to cutting-edge research. It is not just the brightest star in our sky, it is a bridge between ancient wonder and modern discovery. In its light, we see both the past and the promise of what still waits to be understood. As we move beyond the stars nearest to our Sun, the night sky opens into a deeper realm, one shaped by constellations, giant clouds of gas, and distant massive stars. From Earth, these patterns of light seem timeless, familiar. But they are not fixed. They are composed of stars at different distances and stages of life, and some are changing before our eyes. Among the most striking of these constellations is Orion, a majestic figure striding across the sky, recognized by cultures around the world for thousands of years. The Orion constellation lies over 1,000 light-years from Earth, and yet its stars are among the brightest and easiest to identify. 3 aligned stars form Orion's belt, perhaps the most recognizable asterism in the sky. These 3 supergiant stars, Alnitak, Alnilam, and Mintaka, burn with incredible energy. They appear close together from our point of view, but in reality, they lie at very different distances, each thousands of light-years apart. Together, they serve as a celestial landmark in the winter sky. Above the belt shines Betelgeuse, a red supergiant star nearing the end of its life. With a radius hundreds of times greater than the Sun and a surface temperature cooler than Earth's own star, Betelgeuse glows with a deep reddish hue. Astronomers believe it may be just a few 100,000 years away from a supernova, a titanic explosion that will briefly make it as bright as the full moon. If this happens, it will be visible even during the day. Though such an event may be distant on human timescales, it reminds us that stars are not eternal.
Below Orion's belt lies one of the most beautiful and important regions in the sky, the Orion Nebula, also known as Messier 42. Located about 1,300 light-years from Earth, this glowing cloud of gas and dust is a stellar nursery, a place where new stars are actively forming. Even with a small telescope or a pair of binoculars, it is visible as a soft, glowing patch beneath the sword of Orion. Within the nebula, brilliant young stars shine brightly, lighting up the surrounding gas in hues of pink, violet, and blue.
At the heart of the Orion Nebula lies the Trapezium cluster, a group of 4 hot, massive stars that form together. These stars are only about 1 million years old, mere infants by cosmic standards, and their intense radiation sculpts the nebula around them. The light and winds they emit shape the surrounding dust into pillars and waves, creating patterns that change slowly over time. Images from telescopes like Hubble and James Webb have revealed intricate details within this cloud, showing us where stars and perhaps planets are born. In recent years, astronomers using the James Webb Space Telescope have detected hundreds of planetary mass objects in the Orion Nebula. These bodies, with masses similar to or less than Jupiter, drift freely through space, unbound to any star. Among them are rare pairs of planetary mass companions, so-called Jupiter twins, that orbit each other like binary stars. These findings challenge our understanding of planet formation and raise new questions about how such free-floating worlds come to exist. Farther away in the galaxy, but no less extraordinary, we find stars that stretch the imagination. One of these is Uy Scuti, a red hypergiant located in the constellation Scutum. Though it is not the most massive star, it is one of the largest known stars by radius. If Uy Scuti were placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. It is so large that nearly 5 billion suns could fit inside it. This star, and others like it, remind us how diverse and extreme stellar life can be. These distant constellations and nebulae are more than points of light or colorful clouds. They are living laboratories of astrophysics, places where stars are born, evolve, and die. They show us the forces that shaped our own sun and planetary system. When we look at Orion or any other constellation, we are not just seeing stars. We are witnessing a cosmic process, a story billions of years in the making, still unfolding in the cold, brilliant light of distant suns. The Milky Way galaxy is not just our cosmic home. It is a colossal rotating system of stars, gas, dust, and dark matter bound together by gravity. From Earth, it appears as a hazy band of light stretching across the night sky. But from above, its true structure reveals itself. A majestic barred spiral galaxy with vast arms coiling outward from a bright, dense core. This elegant form is the product of billions of years of dynamic motion and stellar evolution. The Milky Way spans approximately 100,000 light-years in diameter. At its heart lies a central bulge, a thick concentration of stars packed into a dense, glowing hub. This region is surrounded by a thin, flat disk, where most of the galaxy's stars reside. The disk itself is not uniform. Instead, it is patterned with several spiral arms that stretch across the galactic plane, wrapping around the core like ribbons. Astronomers once believed the Milky Way had 4 major spiral arms, but newer observations suggest that it contains 2 dominant arms, the Scutum Centaurus arm and the Perseus arm. These regions are rich in both young and old stars, and they serve as the primary highways of star formation. The arms are traced by clouds of hydrogen gas and bright newly formed stars, giving them their iconic glow. Between and among these major arms lie several smaller arms and spurs, including the arm that we call home.
Our solar system resides in one of these minor structures, the Orion Arm, also known as the Orion Spur or the local arm. It is a modest segment located between the Scutum Centaurus and Perseus arms. The Orion Arm spans roughly 10,000 light-years in length and about 3,500 light-years in width. Though it is not among the grander arms of the galaxy, it plays host to many familiar constellations, including Orion, Perseus, and Cygnus.
The Sun, along with the Earth and the rest of the planets, is situated on the inner edge of the Orion Arm, about 26,000 light-years from the galactic center. This places us a little more than halfway between the heart of the galaxy and its outer rim. From this vantage point, we are embedded within the galaxy's disk, giving us a limited, edge-on view of the Milky Way's structure. That is why we cannot see the entire galaxy. We are inside it, looking out. The Milky Way does not stand still. It is a galaxy in motion, rotating slowly yet steadily. Our solar system orbits the galactic center at an average speed of about 500,000 miles per hour. Despite this incredible velocity, it takes roughly 250 million years to complete one full orbit. Astronomers call this journey a galactic year. Since the Sun formed, it has circled the Milky Way fewer than 20 times. Human history covers only the tiniest fraction of a single orbit. Our location in the galaxy is not only interesting, it may also be essential for life. Astronomers refer to a region called the Galactic Habitable Zone, a zone that is neither too close to the violent galactic core nor too far into the dark outer edges. The inner regions of the galaxy contain intense radiation, dense star clusters, and an increased risk of supernovae, which could disrupt the development of life. The far outer regions may not contain enough heavy elements, such as carbon, oxygen, and iron, to form planets capable of supporting biology. The Orion Arm lies within this galactic sweet spot. Here, the density of stars is moderate, reducing the likelihood of cosmic disasters. At the same time, the abundance of heavier elements is sufficient to form rocky planets like Earth. This combination of safety and material richness creates a promising environment for life to arise. Earth's position is stable, away from dangerous regions, yet still within reach of the resources needed to support life over billions of years. While we may be located on an unassuming spur of the galaxy, this quiet corner has nurtured complex life, intelligence, and curiosity. It has given us the tools to look outward and explore the vast spiral structure that surrounds us. The Milky Way is not only a galaxy of stars, it is a galaxy of possibilities. And somewhere among its countless arms and clusters, other civilizations may be looking back, wondering about their own place in this grand celestial wheel. At the heart of the Milky Way lies a region unlike any other, a mysterious, crowded, and dynamic center where stars move with astonishing speed and gravity warps the very fabric of space and time. This is the galactic core, a place hidden from our view by thick clouds of dust and gas. And yet, through radio waves, infrared light, and X-rays, astronomers have found a way to peer through the darkness and uncover the secrets buried at the center of our spiral galaxy. Nestled deep within this cosmic storm is Sagittarius A star, often written as Sagittarius A with an asterisk. It is not a star in the traditional sense, but rather the name of a compact, powerful radio source located in the direction of the Sagittarius constellation. For decades, scientists studied the swirling motion of stars and gas near this region and found something strange. Everything was orbiting an invisible point, moving at speeds that could only be explained by the presence of an incredibly massive object. Eventually, evidence became undeniable. At the center of the Milky Way is a supermassive black hole, with a mass estimated at more than 4 million times that of the Sun. This black hole, Sagittarius A star, is surrounded by a chaotic dance of stars that orbit it like moths drawn to a flame. These stars move at thousands of miles per second, tracing paths that reveal the gravity of a body that is both invisible and immense. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. In the case of Sagittarius A star, the black hole itself cannot be seen. But the material surrounding it, heated to millions of degrees, emits X-rays and other forms of radiation as it spirals inward. These emissions create a kind of glowing halo, allowing astronomers to trace its boundaries and measure its properties from across the vast distances of space.
In 2019, a breakthrough came when the Event Horizon Telescope, a global network of radio telescopes, captured the first image of a black hole's shadow. Though the first image focused on a black hole in a distant galaxy, attention soon returned to Sagittarius A star. In 2022, the telescope team revealed the first image of our own galactic black hole, an orange, ring-shaped glow surrounding a dark core. It confirmed what scientists had long suspected and gave humanity its first glimpse into the center of the Milky Way.
What makes Sagittarius A star especially fascinating is its contrast with its environment. The center of the galaxy is a place of extremes: high energy, dense star clusters, magnetic chaos. Yet the black hole itself is mostly quiet. It does not feed often. Compared to the raging activity in other galaxies, Sagittarius A star is unusually calm. But when it does awaken, it can flare suddenly, emitting bursts of energy that light up the galactic core like a beacon.
Despite decades of study, many mysteries remain. How did this black hole form? Was it born with the galaxy, or did it grow slowly over time by consuming stars and gas? Some scientists even speculate that what we call a black hole might, in fact, be something else entirely. Perhaps a massive concentration of exotic dark matter, or a doorway to another universe. While mainstream science still supports the black hole model, the conversation reveals just how much we still do not understand. Sagittarius A star is not just an object of academic interest. It is a key to understanding how galaxies form, evolve, and behave. It may influence star formation rates in the galactic core, control the flow of matter across the inner disk, and affect the distribution of energy throughout the Milky Way. In this way, the black hole is more than a gravitational trap. It is a kind of cosmic engine, shaping the destiny of an entire galaxy.
To look toward the center of the Milky Way is to look toward our origins. For all its mystery, Sagittarius A star is part of the story that includes us. It is a reminder that even in the heart of darkness, there is movement, structure, and beauty. One day, perhaps not too far from now, we may learn to travel closer, observe more deeply, and finally answer the profound questions that have echoed through our species since we first looked up and wondered what lies at the center of it all. For as long as humans have looked up at the night sky, the Milky Way has inspired wonder and mystery. Ancient civilizations saw it as a river of milk, a celestial path, or a gateway to the divine. But it was not until the invention of the telescope that we began to understand what the Milky Way truly is. Not a cloud or a divine trail, but a galaxy. A vast, sprawling collection of stars, gas, dust, and dark matter held together by gravity. The first major step in mapping the galaxy came from a remarkable discovery in the early 20th century. American astronomer Harlow Shapley used the positions of globular clusters, dense spheres of ancient stars, to estimate the size of the Milky Way. He found that these clusters were not centered on Earth, but instead formed a halo around a distant core. This led to the realization that the Sun is not at the center of the galaxy, but rather located far from it, on the outskirts of a great stellar disk. Today, our tools for studying the galaxy are more powerful than ever. Space telescopes like Hubble, Spitzer, and Gaia have helped astronomers map the positions and movements of millions of stars. Infrared telescopes pierce through cosmic dust, revealing the hidden structures of the galaxy. Radio telescopes capture the faint signals emitted by hydrogen clouds, allowing scientists to trace the spiral arms of the Milky Way like glowing fingerprints etched in space. One of the biggest challenges in studying our galaxy is the fact that we are inside it. Unlike a distant spiral galaxy, which can be photographed in its entirety, the Milky Way must be studied piece by piece. Astronomers create a kind of galactic map by observing stars in every direction and measuring their motion, distance, and composition. It is like trying to understand the shape of a forest while standing among the trees. But through patience, technology, and creativity, the picture is slowly coming together. Through these efforts, astronomers have identified different generations of stars within the galaxy. Population 1 stars are younger, metal-rich stars like our Sun, found mostly in the galactic disk and spiral arms. Population 2 stars are older and contain fewer heavy elements. They are found in the central bulge and the galactic halo, including in globular clusters. A theoretical third group, called Population 3 stars, is believed to have formed right after the Big Bang, but none have yet been observed directly.
These stellar populations tell the story of the Milky Way's evolution. Over billions of years, the galaxy has grown not only by forming stars, but also by consuming smaller galaxies. Traces of these mergers can still be found today in the form of stellar streams and disrupted clusters. Each star carries a chemical fingerprint, and by analyzing these fingerprints, scientists can trace the origins of stars and reconstruct the Milky Way's dynamic past.
Beyond what we can see lies something even more mysterious: dark matter. Though invisible, dark matter is believed to make up the majority of the galaxy's mass. Its presence is inferred from the way stars and gas move. If only visible matter existed, the outer parts of the galaxy would rotate much more slowly. Instead, they spin as if they are being held together by a massive, unseen halo of matter. Understanding dark matter is one of the most important goals in modern astronomy. In addition to dark matter, the Milky Way is enveloped by a halo of hot gas that stretches hundreds of thousands of light-years into space. This halo likely formed through energetic events, such as supernova explosions and galaxy collisions. It is in this halo that many globular clusters and ancient stars reside, orbiting the galaxy in eccentric tilted paths. These stars and clusters offer a glimpse into the galaxy's early history and its continuing evolution. Despite the distance, scientists continue to unravel the secrets of the Milky Way from Earth. Every star we study, every exoplanet we discover, and every stream of ancient stars we trace brings us closer to understanding our galaxy's structure and story. We are inhabitants of a vast spiral, born from its dust, shaped by its forces, and destined to move with it through space and time. The Milky Way is not just where we live, it is a living system, and we are part of its unfolding tale. For most of human history, the Milky Way was a mystery, a glowing band across the night sky that stirred the imagination. Ancient civilizations wove stories around it. To the Greeks, it was milk spilled from the breast of Hera, the queen of the gods. In China, it was a silver river separating star-crossed lovers. And to the Inca, it was a celestial path for souls. But despite its presence above, no one knew what the Milky Way truly was. It remained a riddle written in stars. That began to change in the early 17th century, when Galileo Galilei turned his telescope to the heavens. What had once seemed like a hazy cloud revealed itself as a collection of countless faint stars. Galileo was the first to recognize that the Milky Way was not a cloud, but a dense concentration of stars. This single observation marked the beginning of a transformation in our understanding of the universe, one that would take centuries to unfold. In the centuries that followed, astronomers began mapping the sky in greater detail. Star catalogues grew, telescopes improved, and a new view of the cosmos began to take shape. But confusion remained. By the 19th century, many scientists still believed that the Milky Way was the entire universe. The so-called spiral nebulae, seen through telescopes, were thought to be clouds of gas within our galaxy. The scale of the cosmos was still beyond imagination. A breakthrough came in the early 20th century. Henrietta Swan Leavitt, working at the Harvard College Observatory, discovered a relationship between the brightness and period of Cepheid variable stars. Her work allowed astronomers to calculate distances to faraway stars for the first time. Then, in the 1920s, Edwin Hubble used this method to measure the distance to the Andromeda Nebula. To his surprise, it was far outside the Milky Way. Andromeda was not a cloud within our galaxy. It was another galaxy entirely. This discovery shattered the old view of the universe. The Milky Way, once thought to be everything, was now just one galaxy among many. The universe had suddenly expanded in scale, becoming deeper and more mysterious. Hubble's work not only proved the existence of other galaxies, but also showed that they were moving away from us, leading to the discovery of the universe's expansion and the theory of the Big Bang. Meanwhile, astronomers began turning their attention inward, toward the structure of the Milky Way itself. In the 19-teens, Harlow Shapley used the distribution of globular clusters to determine that the Sun was not at the center of the galaxy. His work placed the galactic core in the direction of the Sagittarius constellation, about 25,000 light-years from Earth. This was a humbling realization. Our planet and our star were not in a special or central place. By the mid-20th century, radio astronomy opened a new window into the galaxy. Radio waves could pass through the dust that blocked visible light, allowing scientists to trace the spiral arms and map the Milky Way's structure more clearly. In the decades that followed, the rise of space-based observatories and digital imaging ushered in a golden age of galactic research. Telescopes like Hubble, Spitzer, and Gaia provided precise measurements of stars, distances, and motion. The 21st century brought even more clarity. With the launch of the Gaia spacecraft, astronomers began constructing the most detailed three-dimensional map of the Milky Way ever created. This mission tracked the motion and position of more than 1 billion stars, offering new insight into the galaxy's formation and history. Combined with data from other observatories, we now know that the Milky Way has grown through repeated mergers with smaller galaxies, cosmic cannibalism that shaped its spiral structure.
And yet, for all that we have discovered, the Milky Way still holds countless secrets. We have never seen our galaxy from the outside. Every image of it is a reconstruction, based on data and comparisons with other spiral galaxies. We do not yet fully understand how dark matter shapes its rotation, how stars form within its spiral arms, or what lies at its outermost edges. The history of Milky Way research is far from finished. It is still being written, night after night, by scientists around the world.
Though it may appear still from our place on Earth, the Milky Way is anything but motionless. Our galaxy is constantly in motion, not only spinning on its axis, but also moving through space. Every star, every planet, and every cloud of dust is caught in a cosmic current. The Sun, along with its entire solar family, orbits the galactic center at an average speed of more than 500,000 miles per hour. Yet, even at this tremendous velocity, one full orbit takes about 250 million years. As the Milky Way rotates, it also drifts through the larger cosmic landscape, pulled by the gravity of nearby galaxies and dark matter. It is part of a small cluster of galaxies known as the Local Group, which itself is only a small part of an even larger collection called the Virgo supercluster. Our galaxy moves within this network like a leaf floating in a vast river, drawn by the gravity of unseen forces that stretch across the universe. Among the galaxies in the Local Group, none is more important to our future than Andromeda. Located about 2.5 million light-years away, Andromeda is the closest spiral galaxy to the Milky Way and the only one visible to the naked eye from Earth. But Andromeda is not moving away from us. It is heading directly toward us at a speed of over 110 kilometers per second. Though separated by immense distance, the gravitational pull between these two giants is undeniable. This motion will eventually lead to a cosmic collision, a slow and spectacular dance between the Milky Way and Andromeda. Despite their enormous size, galaxies are mostly empty space. Stars are so far apart that even when galaxies collide, individual stars rarely crash into each other. Instead, the gravitational fields of both galaxies will twist, stretch, and eventually blend their structures. Over time, the spiral arms will warp, and the galactic shapes will blur into one. This event is expected to occur about 4.5 billion years from now. The Milky Way and Andromeda will begin to merge, forming a new, larger galaxy, possibly an elliptical one. Astronomers have already given this future creation a name: Milky Way, a blend of the two original galaxies. During this process, massive gravitational forces may throw stars into new orbits and trigger bursts of star formation. The night sky, for any surviving observers, will be completely transformed. What does this mean for Earth? Surprisingly little, at least in terms of danger. Though the solar system may be pulled into a new orbit or moved to a different region of the new galaxy, it is unlikely to be destroyed. However, by the time this merger happens, the Sun will be nearing the end of its life. Within 5 billion years, it is expected to swell into a red giant, engulfing Mercury, Venus, and possibly Earth itself. Long before the galaxies unite, our planet may no longer be habitable. Even so, the collision between the Milky Way and Andromeda remains a powerful reminder of how everything in the universe is interconnected. Our galaxy is not isolated. It is part of a web of motion, growth, and change. The stars we see today will not always be where they are now. Over millions of years, new patterns will emerge, and entire galactic structures will evolve. The universe is not static. It is alive with motion, energy, and transformation. Modern telescopes and simulations allow astronomers to model this future with remarkable detail. By tracking the paths of stars and mapping the gravitational pull between galaxies, scientists can predict how the Milky Way will change over time. These simulations show that while the process will take billions of years, the final merger will likely be graceful rather than violent. A gradual blending of two massive families of stars into a single cosmic structure. When we look at the night sky, we are not just seeing the present. We are witnessing a moment in a story billions of years long. The future of the Milky Way is written in the motions of stars, the pull of gravity, and the silent drift of time. Though we may be here only briefly, our place in that story is real. We are part of a galaxy that spins, collides, reshapes itself, and journeys forward, ever onward into the unknown. As our journey through the Milky Way draws to a close, we are left with more than facts and figures. We are left with a deeper sense of where we truly stand. In the great expanse of space, Earth is just a pale blue dot, nestled in the outskirts of a spiral galaxy, surrounded by billions of stars, many of them with worlds of their own. And yet, from this small and fragile planet, we have looked up and dared to understand it all. The Milky Way is not just our home in a physical sense. It is a vast arena in which the story of matter, energy, and time plays out. From the first atoms forged in dying stars to the formation of our own sun and the emergence of life, every part of us is written in starlight. The calcium in our bones, the iron in our blood, the oxygen in our lungs. They were all born in the hearts of ancient stars. We are not separate from the galaxy. We are made of it. For all our limitations, humanity has achieved something extraordinary. With telescopes and equations, with imagination and perseverance, we have reached across thousands of light years and glimpsed the architecture of our galaxy. We have discovered other planets, mapped spiral arms, and even peered into the heart of a supermassive black hole. All of this accomplished by beings who evolved under the warmth of a single star, on a world no larger than a grain of dust in cosmic terms. And yet, as vast and ancient as the Milky Way is, it is just one galaxy among hundreds of billions. Beyond it lies a universe that stretches far past what we can see, a cosmos filled with mysteries still untouched, still waiting. We are a brief moment in its history, a flicker of thought in the darkness. But in that moment, we ask questions. We wonder. We seek to understand. Perhaps that is what makes our place in the galaxy so beautiful. Not our size, not our power, but our curiosity. The ability to gaze into the night and see not just stars, but meaning. To feel the pull of the unknown and respond not with fear, but with awe. The Milky Way will continue to turn. Stars will be born and stars will die. Galaxies will merge, black holes will awaken, and time will unfold in silence. But while we are here, brief as it may be, we are part of that story. Children of dust, carriers of light, a species born from the universe now striving to understand it. This is not the end of the journey. It is only the beginning.
If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.